So our next speaker is Shamik Basu from Verizon USA, and he's going to talk on IoT innovations. So Shamik, yes,
Sure.
yeah, welcome Shamik. Thanks for agreeing to talk. So I'll give a brief intro to Shamik. Shamik Basu currently leads the IoT platform and product suite for Verizon's IoT portfolio. Shamik is the product and partnerships leader with demonstrated experience in driving strategy and products in the mobile and Internet of Things domains. He has led diverse teams to incubate, develop, and deliver to create a $100 to $500 million revenue portfolios. Currently, he leads the IoT platform and product suite for Verizon's IoT portfolio. Shamik, welcome to the event, and I invite you to go ahead with your talk.
Thank you. Rajesh, can you hear me okay?
Yes, Shamik. Yeah.
Okay, great. Let me share my screen real quick, and then I think you may have to enable my sharing.
Shamik, are you able to share your screen?
It says it's disabled for me. Let me.
Yeah. Please go ahead now, Shamik.
Okay. Hold on.
Is it fine now?
As long as you can see it.
Yes, Shamik, it's visible.
That's great.
Yeah.
So thank you for the introduction. And I will say that even though I currently am with Verizon and I lead the Internet of Things portfolio, I've tried to make the materials neutral, where they're not very Verizon specific, but also my independent perspective on IoT innovation, just based on the large number of experiences we've had as a team. That's one thing. And the second thing I'm going to state also is, throughout my journey, first dealing with large scale cloud experiences for customers, then going to the Internet of Things, I've just sensed I shouldn't say a radical shift, but almost, varied levels of commonality between the way humans react and respond to factors and stimuli, to how the things, when they're programmed correctly and orchestrated, and to Christopher's earlier point around, when the right levels of learnings are inculcated, actually behave very similarly. That's one thing. My materials also elevate themselves a little bit. They take more of an industry perspective. So I've tried to focus more around the innovation flywheel, as well as innovation opportunities that come in front of us on a regular basis. So it is tempered away from being more academic, and I think it's a mix of what Tom talked about, as well as what Christopher talked about. It's almost like a mix of the two. So let me start out with what we call the Internet of Things flywheel. And if you kind of follow the progression that goes from left on, starting with the sensor, this is what drives all of the activity in the Internet of Things space, and is also something that will segue into what I've start to look at in terms of the largest innovation opportunities that come to our door that we're actively working on. And I'll give you some examples. And in the course of that, I'll also break away a little bit to show you some examples of how we've kind of utilized the combination of multiple things that are on this slide to actually drive real products in the marketplace, and how we're kind of evolving some of that. Okay. So if you kind of start to look from the left, there's obviously, this flywheel here is a conversion of what you would otherwise consider an IoT stack, right? I mean, any IoT stack you look at starts with devices at the bottom, a network right on top of that, and then there is, a compute layer sitting on top of that, and then there is typically a visualization or a PaaS layer, right? I've kind of veered away from that a little bit, and I've gone away from that only because if you think about why we kind of undertake a flywheel such as this, it typically for us starts with sensors. And when I say millions of sensors, this is back to some of the points that were made earlier. The whole concept of how can I densify environments in a way where we can actually generate, as I said, from the millions of sensors to the trillions of signals. But let's focus on the sensors a little bit. So what we're finding more and more is, sensors go across the industrial and the consumer space. And I think a lot of here are very, very familiar with the consumer space. And the consumer space is anything that's around you, that Fitbit device, the Pebble smartwatch, the Apple Watch, and so on and so forth. But when you start to look at the industrial space, we see such huge diversity in the type of equipment, all the way from heat sensors to condition management sensors to ambient light sensors to PPG sensors, all sorts of things. But one of the things we're also seeing in that space is, and I know that I'm probably going to argue against myself when we start talking cellular only. If you look at the grand scheme of things, the sensors, I would tell you, are the preponderance is really around the non-cellular space, at least today. And the goal is to kind of start to move that more and more towards cellular. And the reason that's that way, and it's also an opportunity for innovation, which is when you start to look at the cellular baseband space, it has technically been a very, very power draining element, which is why when you start to look at the power constraint space, cellular has been a challenge in the past. It is also a great opportunity for innovation, where the DSPs and so on and so forth, and how we can actually go create more system on board and system on chip environments where you can be much, much more power efficient, can truly transform the cellular space. Then you look at sort of the next frame up here, which is video devices. People who are familiar with security cameras that we see all around us are the best examples of it right now. If you kind of just look at the sheer volume, the Nest devices, the Arlo cameras, and so on and so forth, typically performing a very, very point function, right? Evolve that a little bit and start to think about how cameras in the industrial environment, have started doing anomaly detection on the conveyor belt. And they're doing it purely from, capturing, immediately learning or, driving that image through an inferencing engine and immediately notifying another control system that says either stop the conveyor belt. Moving on to connected vehicles. This is what's happening in the connected vehicle space, as some previous speakers kind of talked about. A typical car has about 80 to 100 engine control units, the braking, the gears, all sorts of things. What we're finding in this space is, there's almost a unified and almost of a convergent move towards ADAS systems, which is, automated driver assistance systems. And that's what's driving the sudden move to 5G because of device to device, V2V, and as we call it V2V or V2X communications, which is the vehicle interacting with the vehicle and the vehicle interacting with the environment around it, right? And then let's when you start to think about the device space, none of that is very relevant unless you can start thinking about the signals it generates. And from our experience, what we're finding out is when you start to look at the Internet of Things space, you have to be extremely careful with regard to how many times the device is actually in an active cycle, because it's a direct function of how long or the longevity of the device in terms of battery drain and so on and so forth. So, what we've done, for example, here with the types of engagements we've had in the industry, is we've implemented, very power efficient stacks like NAS. But devices that have TCP/IP stacks, for example, we've implemented MQTT. Technologies such as that are very efficient in terms of a power drain and how many times you touch the device. Typically, also, when you start looking at the signal space, continuous recording of data, typically over Wi-Fi, cloud triggered is very, very memory constrained devices. We're also finding industry taking an approach where a lot of the signals are event driven. So do not report anything from the device, put it in what they call a power sleep mode, and only report something from the device when there's movement. So all of these tactics at play, mostly supported, at the silicon layer. When I say baseband, it's very, very important to kind of have those restrictions and constraints kind of built in baseband. But again, when you start to think about the combination of sensors and signals, how do they make a difference? They make a difference because that data is actually making it to a hyperscaler environment or to a cloud environment. And in that sense, a cloud environment is extremely critical when you start to think about how you run simulations. So if you think about planning for a power grid or planning for the number of signals that will come from an oil and gas kind of environment, the planning cycle always involves this concept of a digital twin. And if you think about what Microsoft has recently announced and their focus has been, how can you create a simulated environment around IoT and factory even before the actual deployment occurs, right? Digital twins are critical. Anything that you look at, in the hyperscaler space has a, for example, you've got Azure IoT Hub, you've got AWS IoT, and so on and so forth. And they're environments that are very specifically designed to serve IoT because actually they can support pipelines of a lot of data, a lot of signals coming in, execution of the models, deployment of the models, and that kind of leads to the verticalization and the actuators. Hyperscalers can give you, as I said, basic visualization, but what we're finding out more and more is, in order to make an IoT solution real, you have to get to this sort of environment, which kind of has the most value in the value stack. Data coming from the sensors is great. Making it to a cloud environment is great. But at the end of the day, this is what drives the business, drives new user experiences, drives better operations, and also drives the reason for doing it, which is typically return on investment, right? And these are examples of these apps are things like PTCs of the world, right? Where you've taken the data, you've applied the inferencing, you're providing, a very, very vertical specific visualization. And why you do the visualization and the analytics is so you can have a full-on feedback mechanism in terms of an actuator back to the device. So the flywheel is critically important because that is what drives why someone would go out and implement an IoT solution in the first place, and how you'd combine every component in the IoT stack to drive these three things that we see more and more in the industry. So let me spend quite a bit of time on that, but let me move on to, I guess, the purpose of why we do IoT. And I've kind of laid out 8 of these only because I feel that they're relevant for the audience, as well as these are things that we run into all the time. So let's start with the first big innovation opportunity, which I believe is the driver and pedestrian safety element. So in the US, we have the US Department of Transformation that publishes a lot of data across cities. And there is about 1 in 88, one death in about a pedestrian strike in about 80 minutes. And I'm sure that's true for the US. When you start looking at other developing markets, it's sort of a higher number than that as well. And typically our answer to a pedestrian strike has always been carry a flashlight, wear more visible clothing, avoid earbuds, all sorts of things. But long term, these things don't work, and they don't work because they all involve change in user behaviors, right? But think about IoT coming to the combination of things that we talked about, which is fog/edge computing interchangeably, and the use of computer vision. And so if you think about companies such as Azuga and our own Verizon Connect, and the measurement of driver behavior such as drowsiness and distraction, it's a perfect use case for how edge-based deployments and inferencing can actually make our streets safe and make intersections much, much safer. Huge area of opportunity for research and research investment. And then you kind of move towards actually, let me switch and show you a video. I may have to share my other screen if you don't mind.
Shamik, you should be able to do it. We have enabled audio,
Okay.
so you should be able to do it.
Got it. Let me.
Maybe unshare this and share that.
I think that's what it. That's what I'm going to do. Yeah. Give me just a second. Sorry, I'm trying to. Let me know when you can see it. I'm just going to play a video, and if you can hopefully. This is an example of something we've done utilizing Dashcam.
This is
So let me
Mike.
play
Howdy.
this.
Mike's company recently installed
Can you hear this?
Verizon Connect integrated video into all their vehicles. Easy peasy.
Yes, Shamik, yes.
Kate.
Hi there.
Kate manages her drivers like a finely tuned watch, thanks to the seamless connection between integrated video and the Verizon Connect platform. Now, if something happens on the road, Kate can see HD video of just the incident within moments of it happening. No need to sift through hours of footage.
Huge time saver.
Notifications and videos can be viewed from any compatible device. With Verizon Connect integrated video, you can coach your drivers and protect your business against liability claims.
All right, let me stop sharing. So hope that provided a perspective on how we're, let me share my screen back here. So that really hopefully provided a perspective on, how we're literally taking inferencing and utilizing fog computing on that camera equipment that you saw, communicating with a hyperscaler platform to detect other objects in the road, and then pushing that data back to a control system for active monitoring of the driver. It's huge with regard to keeping roads safer. Let's move to pharma movement. And if you just look at the post-COVID scenario, 50% of Americans have said they're interested in taking the COVID vaccine. Now, it also means that you're also talking about 45 million doses of COVID vaccine movement. But at the same time, if you think about the companies that are involved, are all saying that they're very, very low on the supply chain equipment that's needed to transport this vaccination at such low temperatures. Right? What is needed, therefore, is not just and as we start to look at the developing markets, you need extremely efficient condition-based monitoring sensors at very, very low cost that can be attached to some of these freezer equipment as well as pallets. And when we talk to our customers, that's what they tell us, that the technology is great, but we really need cost optimization. So let me kind of switch to some of the innovation that we've actually pulled together, that we've worked with one of our partners. Let me switch to that in just a second. Can you see this?
Monitoring and managing assets in a smart, fast, and more cost-effective way than ever before.
You can't see your video.
Shamik, the video is not visible.
I'm sorry. Let me just reshare it. Sorry about that. How's this? Can you see?
Yes.
Okay, that's great.
Throughout the storage, transport, and distribution journey can be daunting.
given stringent regulations. Faulty supply chain logistics in the US cause 40% of food waste and $35 billion in pharmaceutical product losses each year. And 75% of companies experience pandemic supply chain disruptions, all of which impact the ability to deliver on time and achieve revenue targets. Verizon, Microsoft, and Cognizant formed an alliance to help make it easier for businesses to build an intelligent application so they can efficiently manage and use cold storage worldwide. Our solution keeps the quality of food and medicine shipments safe by proactively monitoring and managing assets in a smart, fast, and more cost-effective way than ever before. Verizon's ThingSpace platform, critical asset sensor bundle, and award-winning LTE or 5G network captures IoT data and ensures secure and reliable connectivity. Combining Verizon's critical asset sensors and ThingSpace platform into Microsoft Azure IoT Central brings device data into a unified IoT infrastructure. Cognizant's cold chain monitoring application helps seamlessly integrate these technologies and systems to securely stream near real-time temperature, humidity, location, and other critical asset data into Azure IoT Central for proactive action, reporting, and analysis. Here's how it works. A critical asset sensor can be used on small or large packages or refrigerators, giving supply chain managers a real-time view of the location and environmental condition of each item in a shipment. A temperature log recorded throughout the shipment journey ensures product safety and compliance are never compromised. Vehicle drivers can remotely monitor truck temperatures and adjust settings using a mobile app without making an unscheduled stop. They receive alerts when the cold chain is breached or when a vehicle needs to be rerouted to the nearest transfer point for immediate maintenance. Store or pharmacy managers can use dashboards to check shipment status, prepare for delivery, or monitor refrigeration units throughout their facilities. Managers are alerted when units experience a sudden increase or decrease in temperature.
So let me switch to the core. Hopefully that gave you a perspective on how we're taking, if you think about it, you saw the critical asset sensor. That's a combination of a piece of hardware that we built knowing that there's so many different types of signals. We utilized a partnership, as you've seen, with a large compute environment. And then we utilized a solution, from, working very closely with Cognizant. And what that really tells you is if you go back to the flywheel that I said, it starts with the piece of hardware, it uses a compute environment, both for far compute as well as deployment of those models on the edge, as well as the solution, as I said, that was provided by Cognizant in this case. I'm going to hit, I know I'm up against time, but I'll hit another really important one that I think is very, very, it's starting to become like an emerging area that we're getting a lot of questions about, and which is the automated fleet movement. So, I'm sure folks here are familiar with the whole concept of truck platooning. And what really truck platooning is that it's the linking of two trucks in a convoy. It uses connectivity and it uses ADAS, or the automated driver systems. And what happens is these vehicles, they maintain a very set close distance between each other. So they're, connected for, majority of the journey. And when that happens, the aerodynamic drag by, keeping vehicles together actually reduces a lot. And it also increases safety. So when you start to think about automated guided vehicles in ports and large industrial environments, platooning is actually going to become a very, very important capability and it's almost going to be a must-have in the movement of fleet going forward. And why is that important? One is because platooning cannot happen in a far cloud environment. You have to get the device data from the sensors. You have to process it mostly locally because you almost are talking about between 20 and 40 millisecond latency, for when the device or the truck detects something and it has to brake, or, detects fog, or it detects, an identified object in front of it. Very, very critically important that, computers actually move closer and closer to the device, which is basically what edge and fog computing are. So just to summarize real quick, we talked about the driver and pedestrian safety, very, very important. I didn't get to talk about crop prediction, which I think would be very, very relevant for this audience as well. There are companies that we're working with right now that use tank monitoring as an IoT solution and are seeing, 10, 20, 30% reduction in, their consumption of crop inputs, which is great. We are seeing a lot of demand in the worker protections in the manufacturing, especially in oil and gas, also a huge area of investment. And especially with remote work and businesses having to manage their premises remotely, security monitoring. This whole video camera business is exploding right now. So, these are I just wanted to throw them out there because these are great opportunities for innovation. And I want to leave you with a couple of things here when it comes to kind of applying, some of these technologies to industry. One is, it's very, very important, especially in IoT, to look for white spaces. And I cannot start to tell you the number of companies that came in. I think I'm picking up some background noise if you don't know. So, well, first of all is, Me Too solutions don't go very far, right? And you have all seen a barrage of wearables that have come to market, got no traction because there was not enough differentiation, and Fitbit and some of these others took the entire market. Second, I think it's extremely important to create a digitally activated POC or a lab environment. And this is what we do with most of our customers. Someone mentioned Raspberry Pi. It's as simple as that. Just make sure that the stack is integrated into Raspberry Pi, connects with an hyperscaler cloud environment, set it up as a digital lab experience. That's how we're going to learn more and more about the signals and the data coming in. Second thing is, if you recall the video I showed you about Cognizant, it's critical for multiple reasons. You have to focus on an area in the stack and then start to look at ecosystem partners that actually are looking for a solution such as yourself. And I see this with hardware partners all the time. They're building hardware devices, but they're looking for cloud and compute solutions coming from others. So when you kind of bring the three together, through these lab environments, they actually lead to a very comprehensive and effective solution, as opposed to having to go out and build all parts of the solution yourself. Then the third one is make edge sort of a part of your solution, as opposed to making edge just the lead of the solution and the solution becoming an enabler. And I said a lot of words there, but what's really important is if you just think about the video camera business, instead of going and convincing customers that they have to go out and deploy a full-on edge, think about showing them the outcome where local inferencing and local compute can actually help them drive a low latency result like image recognition. Customers get that. The market gets that very, very easily, as opposed to start to think about a very, very large scale edge deployment. So I'm going to leave you with these three things with regard to how to pursue innovation in the space. One is extremely important to identify the other ecosystem partners. Extremely important to be well differentiated and be able to take the data, accrue the data, and drive outcomes. And third is start with a solution and then fit the edge pieces into place. And that should that brings me to the end of the presentation. I thank Kaushik and Rajesh and others for inviting me. Hopefully you got value out of this, and I'm happy to take any questions if you have any.
Thank you, Shamik. Any question from the panelists? So, Shamik, there are a couple of questions.
Okay.
I'll just read it out. I'm not able to. Yeah. Do you have any IoT example or reference for corporate prediction for study purpose? I don't know what corporate prediction, crop prediction.
Crop predictions, you mean?
Crop prediction. Oh, maybe. Yes.
Okay.
Yes. Okay. Yeah. Okay.
Yeah, there's actually quite a few. Actually, we've worked with a company called Agrium. They're out of the Illinois area. So if you're asking me specific as to which algorithms are utilized, it's probably a IP that they have, and they've actually spent the time kind of building and refining some of that algorithms. But Nutrien is one, Agrium is one, and basically what they do is they specialized in creating models that optimize the amount of crop inputs that actually go in. And these are the guys that are producing data that are saying it's leading to about 5 to 10 to at times 20% reduction in crop inputs for farms, which is great. The other thing you have to realize when it comes to ag tech is that the time of harvesting is critically important to the price of the crop. And environmental factors and crop input factors actually, through the models actually give you some very, very predictive insight into when the right time for harvesting is, especially with things like grapes. And we're finding a lot of the folks in the ag tech space utilize these models very effectively. Hope that helps. I mean, those are the two I can share.
So thank you, Shamik. It was an excellent talk. It gave perspective.
Sorry, I went a little longer, but I just wanted to make sure I shared the videos.
No problem, Shamik. No problem. Actually, it gave a perspective on what one can look for in terms of innovation. So that was this is the last slide with a lot of these applications. That was very useful.
Thank you.
So thank you, Shamik, for agreeing to talk. And
thanks for inviting me. I learned a lot too.